Hello, my friends. In this video, in this course, I would like to show how to build interactive advertising board with React.js, Node.js, machine learning, and AWS. What technologies will be covered in this course? First of all, it's React.js, famous library created by Facebook that helps create interfaces. It's Node.js, JavaScript runtime, DynamoDB, scalable database hosted on AWS. It's machine learning, AWS EC2 instance, load balancer, auto-scaling group. We will also test latency, scalability, throughput using artillery, and we will use Jupyter Notebook to train our model. What are requirements for this course? First of all, I would like to mention that this is not a course for novice students. You will need to have familiarity with Frontend, with Backend. You need to have a basic knowledge of JavaScript, Python, and you need to have basic knowledge of AWS. What will you take away from this course? First of all, you will build interface with React.js, although it's not the most important part. You will build API with Node.js. You connect AWS DynamoDB with Node.js. You will train recommender system machine learning model, and you will learn how to deploy and train model on EC2 instance. So all these pieces will be interconnected in one relatively big app. To run all these programs, you need to install them. I will provide link with Node.js, with Jupyter Notebook, and AWS account. Let's see how our app is functioning. For this, I will probably need to go to AWS account. So I will need to modify auto scaling group because at the moment I don't have any EC2 instance running. Now I have added one desired instance, and here we will have one instance that is currently in pending mode. Now our instance is running. Let's see. So this is our frontend page. It displays various locations that I took from publicly available Yelp API. And when a user clicks on any of these places, then he should get recommendations shown here, but currently it's not showing. Let's see why. It probably hasn't loaded yet properly. Okay, we have problems with post request. It says that failed with status 162. Let's see. Okay, now as you can see, when we move to this page, we get recommendations. We get places that are similar to this place. In this case, we used so-called content-based recommendation system that I will show you in the machine learning part. So this is what I wanted to show you, and let's see in the next lesson. Hello. In this lesson, we will start with building our simple Node.js server. First of all, I have created a folder. So I open this folder, and here I have presentation that I will probably need, but I will remove it later. And let's create an index file. No, first of all, let's make sure that you have installed Node.js. If you installed Node.js, you can check it like that, node space -v. It will show you the version of Node.js that you installed. Now, using special command npm and init y, we can create package.json file. Okay, this file was created here. Let's create a folder, and in this folder, let's move to this folder and let's write npm init. We have created package.json file that will contain configuration for our app and will also contain dependencies that we will use in this project. In this project, we will need the following dependencies. First of all, it's Express. So let's write npm install Express. Then we will need nodemon, body parser, course, Axios, AWS SDK, async, and we will need the following ones. We will need all these packages later in our course, and I will explain how to use them later in this course. You know what? Let's remove this file and let's just copy paste it here, and we will have package.json, and let's just write npm install and install all packages that are contained here. Okay, we have installed all the packages. Now let's try to run our app, and for this we need to create index.js file, and we will need to import our dependencies. Let's initialize and call our Express library. Then we need to connect our course module, and we also need to connect body parser. Let's run our app on port 3001, console log, server. Okay, let's see, npm run dev. Okay, we have problem. It says that address is already in use. Okay, let's try again. Okay, it says server is running. It means that our server is working. Now we need some data to upload this data into DynamoDB. For this, in server folder, let's create data folder, and in this folder we will store all the data we want to, all this data from Yelp API we want to upload into DynamoDB database. For this, first of all, you will need to log into AWS website, and here you need to click services, DynamoDB, and here we will need to create new database, new table. Okay, it says that we have two databases now, like place and queries, and let's create another table. Let's say we'll give us location, and here we will leave it as it is with default settings. It says that partition key is a part of the table's primary key. This hash value. Yeah, we will use string, and sort key we will use also string. Let's create. It says what partition key name you want to have. So let's say we have location key. That's it, and it's being created now. Okay, it's created now, and we now need to upload all this data into DynamoDB location database, and let's create another file. Its file name is let's say it's called map.js or locations.js, like that. And now we need to import some functions from AWS SDK, from this AWS SDK that contains a lot of functions which help us to interact with AWS. For example, we need to import this DynamoDB client and get item command and scan command from AWS SDK. We also need to import these files, marshal and unmarshal, from util DynamoDB, and Axios from Axios. We also need to configure client params, and we need to specify different parameters here, like region and credentials and access key ID and secret access key. To know your credentials, you will need to go to AWS. Here in the top right corner, security credentials. Here you will need to create access key. Check here, create access key, and they will give you a file in Excel format that will contain your credentials that you will need to put here. For example, in my situation, I will take my credentials here. These are my credentials, secret, and this. Ideally, you will need to store them in env file so that nobody get access to this information. But for our lesson, it's okay to keep it here because anyway, I will change it later. Now, we need to write a function that will write our local data, this data, into AWS. Okay, so let's write DynamoDB, new DynamoDB client, and let's provide it with client params. DynamoDB client class is a special class that lets us to get access to all this functionality that is stored into DynamoDB variable. Now let's write path to our local file. It's stored here, and after that we will need to create document client variable, new AWS DynamoDB document client, like that. And let's write a function, export async. This will be a synchronous function because it interacts with remote database. So we have very verbose name for our function, save Yelp business data into DynamoDB. And for this, we'll need to create file stream. We need to use FC module built into Node.js. We need to loop through this file, and let me paste it here. Then I will explain to you how it works. So let's continue our lesson. I have pasted this piece of code. Now I'm going to explain to you what we are going to do next. First of all, in this params object, we have the name of our table. It's called, in our case, it's called locations. Let me check it. If we go to DynamoDB and tables, it's actually called location. Okay, let's rename it location. Now we convert this object into appropriate format that DynamoDB accepts. Then when we loop here, we get the property names from every object in this file, and then we put into DynamoDB table. It means that we write into this table with help of this dynamo send put item command params. When it keeps writing, it logs this statement successful inserted item with ID and business ID. Now when we have it, somehow we don't use this path. Let's see. Okay, we need to write it here, path, and it seems like we don't need that document client. Now we have this function, and we need to import it here like that, and then we need to write an endpoint, get endpoint here, app get / async request response, and then we need to call this function to write into database. Sorry. Now let's run the server, npm run dev. Did you mean to import locations JS? Okay, server is running on port 3001 now, using Postman. By the way, you can install Postman extension here. It's more convenient than to have a separate application for that. So this extension, and after installation you will have this icon to be appeared here, and let's go to this. You can actually create a folder here like that, and then you can create the API here, endpoints here, and yeah, let's just initiate this. Let's trigger this endpoint and see what happens. Ideally, after sending this request, we start the process of writing these items local data into DynamoDB table. Let's see. Nope, we have a problem. fs is not defined. Okay, let's see what happened. Oh yeah, there was a problem because I didn't import fs from. Now let's try again. We have another problem. Read line is not defined. Yeah, probably I need to import readline to here. Import readline from readline like that. Unexpected end of JSON output. Okay, let's see. Why is the problem? Location here. Data. Okay, in this video we will finally insert our data into DynamoDB. I have made slight changes here. For example, I have moved all my secret codes, access keys, AWS region, and AWS load balancer URL into env file, and I used .env package, which you can install with npm install .env. Then I use .env and called config. After that, I use process env and wrote all these variables that are in env file here. Then I used ef read file sync and JSON parse JSON data. First of all, to get data in string format from this file, Yelp Academic Database Business JSON, I used format like that to format my JSON file. Then I converted it into UTF-8. After that, I parsed all the items and I looped through these items, and finally I inserted into my DynamoDB database. Let me show you how it works. First of all, let's run the server, and as you can remember, we have created endpoint and we called this save Yelp business data into DynamoDB function. And when we send this request, you can see that we have successfully inserted item with ID and its ID. So let me show you my Dynamo database, and let's go to explore table data, and we have about 800. Let's see how many items we have. Yeah, we have about 808.3, oh sorry, 883. One small change you need to do, for example, here you need to write location key. Okay, see you in the next lesson. Hello, in this lesson we will cover the following things. To start with, we will write an endpoint to get all the items from DynamoDB table which we created in previous videos. Then we will write an endpoint to get only one item from the same table. We will use query for pagination. We will cover what is unmarshalling and what is marshalling, and we will look into scan command function from AWS API. Let's get started. Now, when we have written all our data into DynamoDB table, we should comment out this code, because we don't need to save our data into DynamoDB table whenever we hit this endpoint. We also need to comment out code like that. We need to comment this line too. Now, let's write next endpoint that will help us to retrieve all the items from DynamoDB. Export async function get items request response. Then let's write pages rec query pages like that, and let's console log pages, and here let's write an endpoint. Okay, we don't need to write an endpoint, we just need to write here another app get, and when we hit location like that, we need to call this function get items. Okay, now let's make sure that we are running the server. It says we have a problem. Did you mean import location.js? Where is that? Locations. Okay, now it's running. So let's go to Postman, and this endpoint get all business. We can write. Okay, let's leave it as get all business. And now if we want to use queries, we need to add questionnaire mark, then pages, the name of parameter and value, for example 10. And now when we hit this endpoint, here it's not map, it's actually locations. Let's make sure that it is location. Now when we hit OK, because the port is 3001, now we get 10. It is what was const logged in here, 10. Now we need to write params because our scan command from AWS API expects some commands, pages like that. Oops, sorry, it should be object, and table name should be location, and the second parameter it's limit. And we say if there is a pages parameter, if it is not undefined, we need to parse int. Basically we need to convert string into a number, because when it comes from query it is in string format. We say that if we didn't provide any parameter there, we by default use 10. Now we need to write try catch, and in the catch we will console error our error if there is any error. Then we send the status 500 and we will send this error. In try block we will get data, await DynamoDB send and new scan command and params. So it says DynamoDB is not defined. Okay, because it's await, not await. And when we got the data, we need to use, and then we need to res JSON. So let's see what is scan command and what is unmarshal. And if we go to AWS official document, we see here that scan command input, the input for scan command. The scan command operation returns one or more items and item attributes by accessing every item in the table or secondary index. To have DynamoDB return fewer items, you can provide filter expression operation. Okay, and if we look at unmarshal, so what is unmarshal? Unmarshal converts a DynamoDB record into a JavaScript object. Now let's hit this endpoint and let's see what we get from this API. Okay, we didn't get anything because we can see error cannot read properties of undefined reading map. Let's see why. We can debug this, and it says that there is no items in data. Okay, because it's not items with small letter, but it's with capital letter. Okay, good. As you can see, we got our first 10 items from DynamoDB. And now let's write the second function, which will give us only one item by ID. So export async get item, and here we provide request response. And first of all, we need to write params that we pass into scan command. We write table name, that is location. It is probably the best idea to make it as a variable. Let's make it table name location like that. Now second parameter, it is key, and we use Marshall, and it expects the location ID, which is here, location key, like that, and should be request params and ID. Now after that we will write try catch, and we can copy it from here, and here we can write const data await DynamoDB send new get item command. It is another function provided by AWS API. Const item equal on Marshall data item, and we need to send it to the client like that. So let's see what is Marshall. We look into what is unMarshall and what is, let's see what is Marshall. So basically Marshall, it is opposite process. It converts a JavaScript object into DynamoDB record. And let's look into get item command. So get item command operation returns a set of attributes for the item with the given primary key. If there is no matching key, get item does not return any data, and there will be no item element in the response. Okay, now let's use Postman. Oh no, let's go here and let's write another endpoint to get only one item. For this we need to write app get, it will be /location /ID. We will import get item from there. Now let's go to Postman, and we don't have get, let's add new request, and now in here we need to write ID after location. For example, let's go to our DynamoDB table and let's copy this ID here, key, and we need to go here and paste it here, and let's see whether or not we have a successful return. Okay, we do have a successful return. So it's business name MH Commander Bridal. Let's see here. It is, yes, it is MH Commander Bridal. Okay, thank you for attention. See you in the next lesson. Hello. In this lesson, we will continue with our project, and we will also learn about filter expression attribute values, and last evaluated key. In this lesson, we will write a function that will help us to retrieve items by their names. Let's give this function a name, get items by name, and it should have request and response. There is an error here. Let's fix it. And from request query, we need to get 3 params: its name, its limit, and start key. Request query like that. Now, as usual, we need to write params, and table name will be table name like that, and filter operation will be business name that equals to name. It means that equals to this name which we provide. Business name here. Next we need to write expression attribute values that equals to name as name, and I will provide explanation a little bit later. Limit parse int limit undefined, and exclusive start key equals start, and start not undefined, and start key not equal empty string. So if this is true, then we need to parse start key, and if it is not the case, we will return undefined. And further, we need to write, we will console error rest status and send like that. And here we need to write data await DynamoDB send new scan command params const items equal data items map item on Marshall item, and const response will be items, and last evaluated key will be data. So what does filter expression mean, and what it does? Filter expression is used to filter the results based on the business name. Expression attribute values provides values for the filter expression, for the name placeholder, for the actual business name that the user provides. And limit specifies the maximum number of items to return, and if limit was provided in the query parameters, it will be used after being converted to an integer. Otherwise, no limit will be set. Exclusive start key used for pagination in DynamoDB if the start key is provided and if is neither an empty string nor the string undefined, it will be parsed as a JSON and used. Otherwise, no start key is provided. Okay, what should we do? I think, yes, we didn't return res JSON response like that. And now we need to test this function, but before we test this function, we need to write the endpoint get and location, and let's write here search, and let's put it here like that. Okay, now let's open Postman, and we can use, let's create a new request. It should be search here, and we will use params, and the first parameter, it's, let's take a look. The first parameter, it's name. For example, name equals what we have here. Let's take this name. Then the second parameter, it's limit, and let's have limit 10, for example. And let's try. Okay, it doesn't work. Why? Let's take a look. Oh, we don't have our server running. Okay, it says couldn't send request. Now server is running. Let's try. Okay, there was a problem. No value defined 93. Oh, did we use the function? Of course we didn't. Okay, get items by name, of course. Now let's test again. Okay, no result. There are no values defined. Let's take a look. Let's debug. Let's see if we get any name or limit. Okay. No values defined. Okay, it's complaining at get item. Oh, I think I forgot the / couldn't make requests. Error. Error is not defined in. Oh, of course it should be error. Let's take a look again. Yeah, sure. We have response. Oh no, or not. We have validation exception for client 500. Filter expression is null. Oh, I see. It should be expression, not expression or something like that. Yeah, let's try again. Now we get something, but we didn't actually get anything here. Let's try again. It means that it didn't find anything. Why is that? No items. Okay, good. The problem was I used the quotes, which I didn't have to. Okay, now we see that it works now, and we can find places by name. Great. Let's call it today for this lesson. See you in the next lesson. Hello everyone. In this lesson, we will continue with our project. First of all, we will install React. Then we will create main page, and we will connect our server to get organizations from backend. Let's get started with installing React. To install React, we will use create React app. We need to go to our root, and let's see what we have here. Here we have server, and we need to create client folder. For this, we need to write make dir client like that. Now, as you can see, we have client folder. Now we need to go there, cd client, and here we need to write npm create React app and space and dot like that. It means that we will install React in the current folder. To be precise, in the client folder. Okay, something is wrong. npm create React app. Create React app dot. Okay, now it will start installing React application, and it may take from 1 to 5 minutes depending on the resources of your computer. By the way, this dot means that we want to install React in the current folder, in the client folder. I have installed React app. Let's go to, oh, okay, we are in the client folder already. Let's type npm start to start this application. Okay, now our client part is launched. Let's open editor, and okay, I think we need to write to open another editor, which we will use for our client. And oh, by the way, we don't need to actually, because we have everything here. Let's remove everything we don't need, because by default we have here unnecessary code that we can clean. Let's remove this logo. Let's remove test. Let's remove this logo. Let's remove this, and let's remove, and we don't need this one. We don't need this one. Let's see. Okay, now we have clean page. And first of all, let's install some packages. For example, we will need Axios package to interact with our backend. And in src folder, let's create another folder called Axios, and inside Axios we will create instance.js file. In this file we will import Axios from Axios like that, and we will write our base URL. Base URL is HTTP localhost 3001, and let's export instance, and let's write Axios create base URL. By doing this, we will not need to write our base URL every time. Then let's create another folder called config, and let's write organization.js like that, and let's import our instance that we created. Let's write export const get all organizations. It will be a asynchronous function that will take in number of pages, and we will return await instance get, and let's write endpoint. Our endpoint is, let's take a look into our server. Our endpoint is location, yes, location/location, and we use pages params that accepts number of pages, or in fact it's number of items, and returns data like that. Let's create context folder, and let's write organization context.js. We need context because we don't want to pass our props through various layers. We will wrap our code with this context, which will give us possibility to receive props directly from any page that is wrapped with this context. And let's write export context wrapper that receives props, and let's write state, use state, and we will return organization context provider like that, and here we will write props children, and here let's write value organizations, set organizations, and let's write here the functions that we will clear fields. Now we will need to wrap our code in index page here with context wrapper. By doing this, we make it possible for any components that wrapped with this context to directly get access to the state that is defined in the context. Another package I would like to install is npm react router DOM. This package is necessary to navigate through the pages. Let's import the following route and routes from, like that. And let's remove this. Let's write browser router, like that. Here we will define routes, and inside we will define route with path, so it means that it is home page, and let's paste it here. Now let's see what we have here. Let's open. Okay, now as you can see, when we show the app page, we show this page that is hello. Now I think that I will continue in the next lesson. In this lesson we have installed React, we have set up basic functionality for our application, and we also set up routes for our apps. And see you in the next lesson. Hello. In this lesson I will continue with our project. Next thing I would like to implement is adding of the input that will be used for searching. And let's add input. Let's add form, like this. I want to remain this div, and I want to give it a class, this container class, which has the following properties. Let's see, what do we have? We have an input here. Next thing, I want to get data from DynamoDB, and I can do it by importing use context. And in this use context, I want to import organization context. Further, I want to extract values from this context. Namely, I want to extract organizations and set organization. Let's import use effect as well. In this use effect, we will call get all organizations function that takes in a parameter. It's called items to show. Set items to show. Initial value will be 10. In this function, in get all organizations, it is function that returns promise. That is why we can use chain them items set organizations items, and it suggests us to update the array of dependencies with items to show and set organization. Let's see what we have in our console, whether we get items from the back or not. We have a problem. Let's see why. Let's look into our context. Oh, what I'm doing here, I just confused. It shouldn't be here, it should be here. This should be here as well. And we can remove this one. We can remove this one. We need to import use effect, this function. We need to import this from the context. And let's see if we get anything. Use state is not defined. Okay, let's import use state, and it cannot destructure property organizations of null. Let's see why. We have wrapped with the context wrapper. Yes, actually it should work. Let's see. We probably have problem here, and the problem is that Here we should have use state like that, and we don't need use effect, use context, sorry. Let's uncomment this one. And of course we need now the structure, set organizations, and clear fields. Okay, we don't get anything. It means that this part doesn't return anything. Okay, I have changed my code a little bit. Now let's see our console. Now we can see that we get our data from the server. After this, I think we need to show our data on the page. Thus, the further step will be to iterate, to map through the data, and let's see, business name. Here we have names of our company that we fetched from the DynamoDB. I think that I will continue next lesson, where we will create a separate component for each business item. Hello, my friends. Let's continue with our project. As I said in the previous lesson, we will create a separate component that will display organizations on our page. Let me show how we will structure our components. Let's imagine we have a list which contains more components like that. So this is first component, this is the second component, this is the third component, and each component will have its own properties. For example, this component has its name, next, and all these components will share the same properties. This name, also name, and it will contain also other details like address, and this one will also contain address. For this, in the source folder, let's create another folder that we will call components. Inside components folder, we will create organization folder. Let's create organization file and organization CSS, and using special command called roughc, it's basically snippet. Yes, it's called snippet, to create template for our component. And let's also create inside of components folder, inside of organization, let's create organizations list component. It should be file, not folder. Organizations list JS6 and organizations list CSS, like that. Using roughc, we will create a template, and let's export this, or import organizations list right here, and we see organizations list on our page. After that, let's go to organizations list, and next we will need to destructure organizations from use context, and pass in organization's context. Next, we will check if somehow our organizations is not an array, because we expect that we get a list, but sometimes it can come as something else. For this, we will check if it is not list, we will show no organizations available. But if it is the list, we will add class name organization list, and we will iterate with the map organization index, and here we will return another component called organization or organization, and we will add key here, and we will pass organization as a prop. Now we will see that we have first 10 organizations. In organization, we are accepting organization, and organization component will have the following structure. Let's write div, let's give it a class organization item. Inside organization, we will have the link, and this link will redirect to different page organization, and here we will provide the ID for organization. Let's see, let's go here and let's see what we have in our DynamoDB. And we have location key, these unique keys. Let's select this and write here location key. And here we have h2 tag, which has organization business name like that, and also it will have more information like organization business address and organization categories, image. Since we don't have images in our database, we will provide fake image, because the goal of this course is not showing you how to implement the front-end part, but how to implement machine learning and cloud computing parts. It says what? Okay, it says that it is redundant. Let's remove that. Business. Okay, the image word was not necessary. Now we have organization list that contains all these organizations, and let's see what we have here. And it says that location key cannot location key. Okay, let's see why. Pass in organization, and here organization like that. Okay, we get our organizations shown on our page. And let's do some modified. Let's add some style. First of all, I will just add it here, this design, and I will import or like that. And here organization list, I also paste it here, and I also import CSS. Okay, so when we click the name, we should go to the next page and to see some details about this organization. And this part I will continue in the next lesson. Hello, in this lesson I would like to continue with this project and to create organizations details page. First of all, let's create component organization details JS6 as well as organization details CSS, just like that. Using snippet we will create template and I will import organization details CSS. Let's just paste this CSS for organization details, and let's write use state, and we will add loading, set loading, and we need to use params hook to get this ID here. Now we need to write use effect. We also need to add here another function that communicates with our backend. Get organization by ID, async ID, and let's use this function in our organization details page. Inside here we will call this function, we will pass ID. We also need to import this function, and then we need to attach then, and let's see what we get here in data. Okay, we can see that organization 6, let's remove it here, and let's go back. Okay, we organization list 17, let's remove it. And I forgot, we need to add to the route here, should be organization details by ID. Okay, now we see that we get data and we need to extract this data. Let's extract this data like this, and we get our object, which we will set. We should set this, and probably it should be here an object which we will set. And when we get the data, we should add set loading false, like that. And here we will display our data. Let's add class name to our div. This class name will have organizations details container, like that. And this div will have the following class, or organization details. And we will add condition. In this condition we will write if loading and organization length, if it is loading, then we will show this, we will show the div, the organization is loading, like that. Otherwise we will show the content. Okay, now organization details, Okay. Now, after this header, we will have address, and this p tag should be actually inside this div. We can actually remove this div, and here we will write organization business address or nothing. Organization address. We will also have an image, and src will be https fake img pl 600 by 4. And we will also have div where we will show the review, and this div will have the class organization review, and inside this we'll have title customer review, and let's just, it will be fictional, that's why I think we can paste it here. It will be static information, and we need to actually have this function that converts hours. So basically it gets an object hours. Let's see, object hours, it is in the following format, like this. It's in queue value pairs, and show it in the following format. I think that it's enough for this details page. As I said before, it is not the main objective of this course. It's just for content. The main part is, of course, machine learning and cloud computing. In the next lesson, we will add the button that fetches more places from the database that we will place below here. Hello, my friends. In this lesson, we will continue with our project, and I think that we are going to implement searching mechanism in this application. We have an input here, and I think that we need to add a search button here. For this, we need to go to our code. We need to add a button here, like that, button, and let's give it a name. Let's take a look. Yes, we have a button here. We will not style it in this course, but feel free to style it later if you want to. Next, we have a button, and we need to add a handler. For this, let's write on click like that. Let's give it a name, on search handler, and let's write this function on search handler. This search handler takes in an event object. Now I want to console log target value to make sure that we can write and see something in the console log. For example, I write it here and I can't see anything. Why? Because, of course, we need to implement a state. Let's write here const search set search use state, and initially it will be an empty string. Now, next we need to give this a value. The value will be search, and on change we also need to give on change, of course, and we will change the state like this. and it will take e object. Now we can see, if we console log search, we can see, as we write here, we can see that, so we can't see anything here. Let's explore why. We changed state, we added a state, we gave value. Let's write type. Type will be text, and let's give it a placeholder. Search, and let's remove this organizations list. Okay, as you can see, when I type here, I get it consoled out. The next part is to implement on search handler. It doesn't need this one, and we don't need console log. Now we need to write logics for searching place by a name. By the way, we actually need this one because we need to prevent default like this. We should add here type submit. After that, after we prevented default, we need to clear our state organizations to empty array. We also need to give it params. In params, name will be search and limit will be 10. It means that if we find something with similar name or places which contain substring of something, we will limit it to 10. But in our case, we will search only by the entire name, by the entire match. We also need to write here let last evaluated key. It is what is required by AWS, because when it gives you something, it gives you, for example, 5 first, second, third, 10 items, and it also should remember what was the last one. And we check if they provided last evaluated key, then we need to, if it didn't provide, if last evaluated key is null initially, we need to assign to start key, param start key, JSON stringify last evaluated key. Initially, last evaluated key is null, and it is null, of course, initially, but after several times it will be reassigned to this start key. Then we need to write in context an API. We need to implement a function that will give us places by name. Let's write export const get organization. It will take in name limit start key, and we need to check const encoded start key equals start key, and if there is a start key, we do this encode URI component JSON stringify start key. Otherwise, we return empty string, and then we need to return here await instance get location search name will be name, and limit will be limit, and start key will be encoded start key, and we need to get data. Now we need to make use of this function. Here we need to import this function, and which takes params, and we need to chain then response. We will call set organizations hook and pass in response items like this. Then we will reassign last evaluate key equals response last evaluate key like that. And after that, we will clear the form here by calling it right here. And I think that we don't organizations, do we? Okay, we will. Now let's check if we have the logics for searching by name in our backend. For this, let's go here. Yes, we do have this function, and okay, location search. Okay. Now let's take a look. For example, if we try to search something, for example, Union Bulls Barbershop. Submit. Yes, we have found an exact match. Yes, as you can see, we have one item in our array. Great. Okay, so I think that in the next lesson we will continue with our project. In particular, we will look into how we can load items by load locations by 10 items. It is called infinite loading. See you in the next lesson. Hello, as I mentioned before, in this lesson we will add a button that we can use to load more items. We are going to add this button right here. All right, let's go there. Let's go here and put this button right under organizations list. We will call it, how can we call it? Load more. I think it is an appropriate name for our button. Right here, as we can see, it is just attached to the button, and I think that we need to add it more space. For that, let's give this button a name, load more button, like that. We will write margin top, let's say 20 pixels, and margin bottom 20 pixels as well. Let's see what we have here. Now we have some space between organization list component, and it is also a little bit away from this margin. The next thing we need to do is to add on-click event, set items to show, pref plus 10, like that. We also need to show this button if we have something on our page. For example, we can say if we have more than one organizations, we can show this button like that. So let's give it a try. If we click here, okay, great. We see more organizations. We fetch these organizations right from DynamoDB. Amazing. I guess it is enough for this video, and see you again in the next one. Hello, in this lesson we are starting a new section, machine learning section. In this lesson I would like to go through what we are going to cover in the next lessons. To start with, we will look into what is machine learning. After that, we will talk about what it solves. Then we will talk about types of machine learning, role of machine learning in recommender system. After that, we will also talk about types of recommender systems. And finally, we will get to content-based machine learning recommender system. To begin with, I would like to look at what is machine learning. Well, machine learning is a subset of artificial intelligence that enables computers to learn and make decisions without being explicitly programmed. It uses algorithms and statistical models to analyze and draw insights from patterns of data. What does machine learning solve? Well, it helps to automate analytical model building. It facilitates in making predictions or decisions without human being intervention. Machine learning can process huge amounts of data and find out specific trends and patterns that would not be apparent to humans. What are the types of machine learning? First is supervised learning. It is the algorithm that is trained on labeled data, meaning that the data is accompanied by correct answers. Unsupervised learning, the algorithm is trained on unlabeled data, discovering hidden patterns without explicit guidance. And the third one is reinforcement learning, when algorithm learns by interacting with the environment and receiving feedback in the form of rewards or penalties. In our project, we will make use of content-based machine learning algorithm. What is content-based machine learning? Content-based machine learning recommender system. This is a system that uses item features like genre or director or description to recommend additional items similar to what the user likes based on their previous actions or explicit feedback. For example, if a user watches a lot of action movies, the system will recommend other action movies for them. And I think that in the next videos we will slowly delve into machine learning part of this course. See you in the next lesson. Okay, from this lesson on, we will work with machine learning part as I said before in the previous lessons. First of all, if you have installed Jupyter Notebook, you can see, if you have Windows of course, and I on the 3 like that, you can go here, Jupyter Notebook, and it will open this page like that. What we need to do next is to create a folder. Let me rename this folder tutorial like this. Keep in mind that this is not a comprehensive course on machine learning, and I will provide some helpful links that will help you understand or to learn more about machine learning. Let's create Python 3 file like this, and we can rename this file, for example, commander something like that. It's up to you what name you want to give to this file. Next, to work or to create a recommender system, we need to install several libraries. First library is pandas, and second one is numpy. Third one is sklearn. As you can see, it says requirement already satisfied. Pandas, numpy, sklearn have been installed. After installation of these libraries, we need to import them. We imported these libraries and gave them alias pd and psk so that we don't have to write entire name. After this, we need to import dataset which we will work with, and in our case we will work with this Yelp academic dataset business JSON. There are about 1000 items here. What I want to do is reveal in Explorer, and then I want to paste it here, or I can try to load this data like that and upload. I will also provide this data set in the description. After that, we need to import this data. We can use pd, it means panda. It has this method read JSON because our data is in JSON format, and you can write first several letters and then press tab, and it will do for you auto completion. We have loaded the data. Now we need to convert this data into CSV because we need to work with CSV format, not JSON format. And let's give it a name, for example, Yelp dataset CSV.csv format, like that, and let's run. After that, we need to read this data. Convert the data pd read CSV, like this, and we need to give it this name, and we can run. Great. If it doesn't throw an error, everything is all right, and we can move on. To see what data we have, we can call this head method, and it will show us this table like that. And this table has various information. For example, it has business ID, name, address, coordinates, postal code, categories, hours, and something like that. And for our machine learning part, we don't actually need all the columns, and in particular, we don't need such columns like address, postal code, latitude, longitude, is open hours, because they are meaningless in our case, because we will use natural language processing approach. We will analyze names and categories of each place, and then we will recommend a place based on similarity of names and categories. For this, we can drop these columns. We write drop cols, it means drop columns. Here we need to write columns which we don't need. For example, we don't need address, we don't need postal code, we also don't need latitude, we don't need longitude, we don't need is open, and the last one We don't need this column hours. Now we can write the following. We can write df, it means data frame. So this is data frame, and we can target converted data, so this data, and we can call drop method and provide drop calls, and axis equals 1, and let's run. Okay, we run, and let's call head on data frame, and as you can see, we have data frame, new data frame. However, it doesn't have these columns. I think that we will continue in the next lesson. See you there. Okay, let's continue with our machine learning part. Let's write df data frame. Let's look into categories, or sorry, into attributes here. We can access this column like that, attributes. Let's run and see what happens. As you can see, we have access to all these attributes for all 1000 items here, or we can access, for example, for only first one. And as you can see, we have here a lot of attributes, and to access the second one, for example, like that, or to access the third one, we can get information. For example, here we access the fourth one. As you can see, it has this data. Sorry, this one, right? Now what we need further is to convert string representations in attribute. This data structure in attributes, they are represented as strings. We need to convert it to actual Python data structure, and then we will expand dictionaries into data frame columns. Let's take a look how we can do that. For this, we need to write a function, but before writing a function, we need to import special library called ist. And here we will write a function called convert attributes that takes in attributes So this is a helper function which will help us to convert the strings into actual Python data structure. Then we will need to rewrite the attributes column with actual convert attributes with actual Python data structure. It means that we will apply this function to every item in this data frame. As you know, we have 1000 rows here. Let's run. Great. And now we need to write the following: attributes df attributes apply pd series, like that. Let's run. Okay, and let's see now. Df had, for example, 200. Okay, so as you can see in our attributes, so these are attributes in the form of column. It means that every attribute now has its own column, and we basically don't need some of these columns. That's why we can drop them. We can rewrite this value, attribute df equals attribute df drop, and we can provide an array of items that we don't need. Let me just paste it here. We basically don't need business, accept Bitcoin, smoking, music, good for dancing, accept insurance, best nights, BYOB, Korkic, and the last two ones. We don't need them, and we can write access one like this. Let's run, and let's print columns. Okay, now we have columns which we actually need for our task. And now let's take a look at our data frame. Now we have our attributes in the form we actually need. And the next, we need to actually expand. We need to expand with data frame, where we will add more columns with these attributes. Let's see how can we do it. We can write df pd concat. It's built-in methods that is provided by pandas. df drop, then we can write attributes. Attributes, it means that we drop this column, we don't need this column anymore. Access 1, and here we say that we want to actually attach this one, extend this table with that one which we created here in attributes df, and we can write access 1 like that. Let's see what we have, and let's see the head now. Okay, as you can see, now we have the columns that we go before and extended with all these categories now. Great. I think that we will continue with this project in the next lesson. See you there. Hello. Let's move on with our project. To start with, I want to look into categories column, df categories. Let's see what we have, and we have here 1000 rows, and in these rows we have as a string we have some phrases and words that we will make use of in our machine learning model, for building our machine learning model. I would like to create additional column called content, like that. Content. This content will be a concatenation. It means that we are going to combine name and we are going to combine categories, like that. Oh yeah, do we? Yeah, just okay. Yeah, let's just let's insert a cell below like that, and we will leave it as it is here. But I would like to, as you can see that here in our data structure we have this NaN values, right? So we don't need these values. That means that we are going to actually fill these values with false, or with, we actually will make it false, because we need to have a consistent data. Yes. For this, let's write attributes like that, and I will just copy this array of strings, basically these categories, and I will loop through every column in attributes, every column in this array, and I will access column and fill NA false, in place true, And let's see what we have now. df head. Now, as you can see, all these values that had an a, now they are false. After that, we need to continue. We need to create additional column and combine name and categories like this. And let's take a look at head. What we have now. Now we have additional column content. It is actually a key column that has a name and it has basically categories like department stores, shopping, fashion. And we will use this content to analyze our content and to build so-called similarity index matrix. I think that we are going to continue with similarity index matrix in the following lesson. Great. Let's move on with our project. Next, I would like to implement so-called machine learning algorithm which will create a matrix of similarity index that helps to determine whether or not a certain place is appropriate to the place which we are searching or which we are viewing. For this, we need to use TF-IDF vectorizer. It is a special algorithm, or rather it's a tool from scikit-learn library. It converts a collection of raw text documents into a matrix of term frequency dash inverse document frequency features. Let's see. First of all, we will write the variable TF-IDF vectorizer. It takes analyzer as an argument. It also takes n-gram range, which I will explain later, and it also takes in mean df0 and stop. Then we need to create another variable TF-IDF matrix equals TF fit transform, and it will use our content which we created earlier. Now let's make sure that we have imported TF-IDF vectorizer. We write from scalable dash feature extraction dash text import f vectorizer like that, and from scalable matrix like that pairwise. We need to import linear kernel. So let me explain to you what all these parameters means. Basically, TF-IDF vectorizer, it's a method or function that takes in analyzer parameter. This parameter means the future should be made of words rather than of characters or other things. ng range equals 1 to 3 tuple. This will consider unigrams. It means that single words, bigrams, 2 consecutive words, or trigrams, 3 consecutive words as features. For example, a single word may be set, a verb set, double verb, double words may mean set up, and 3 words feature may be, for example, set up in. Also, min_df equals 0. It means that words should be included even if they appear only once in the dataset. And stop words English will remove common English words like and, the, and etc. from consideration, as they usually don't add significant meaning in most cases. And tf_df matrix feed transform means that this function learns the vocabulary from this column and then transforms the data into tf_idf matrix, in which each row in this matrix corresponds to a document in df content, and each column corresponds to a word or n-gram in the learned vocabulary. And these values in the matrix represent the tf_idf scores, which indicate the importance of a word to a document relative to the entire collection of words. Okay, so let's go and run. We have an issue from feature extract. Okay, should be extraction. Great, now we need to rerun entire document. Okay, now let's create cosine similarities equals linear kernel, and it takes in tf_idf matrix and tf_idf matrix like that. And let's see what we have here. Now, what linear kernel function does, it calculates the linear kernel between two sets of data. In the context of tf_idf vectors, this linear kernel is equivalent to calculating the cosine similarities. Basically, it computes the cosine similarity between every pair of documents based on their tf_idf representations. Cosine similarities measures the cosine of the angle between two vectors, giving a measure between 0, it means completely different, and 1, it means completely similar. In the next lesson, we will see how we can import this cosine similarity index, and then we will use it in our project that we will host on AWS EC2 instance. See you in the next lesson. Hello, let's continue with our lesson. Now, when we have similarity indices, we can provide the most similar items for a given item. Let's say we're looking for the top 5 similar businesses for the business at index 0. Let's write similar indices equals cosine similarities 0 arg sort, and we will get from -6 to -1, and I will explain to you just after, and I will explain to you right after we write our code. Cosine similarities 0, then I and df business ID, and we need have here parentheses like that, and we need to close parentheses right here like this, and for I in similarity indices like this. Well, basically what it does, we sort our indices with arc sort. I mean, we sort our items in this matrix, and we say that we want to have, for example, first item from our array, and we need it sorted and to get only top 5 items. And here we want to, for each item in similar indices, we need to give a similarity index of business at index y with our first indices. Basically, we create a tuple where we have our ID here and the cosine similarity index for each item. So for example, let's print similar indices like that, and what we have now for our first item in this array, we get the most similar places. For example, so first, it means that first is 1, it means that it fully matches because it compares itself with itself. And the second is 0.2, then 0.14, then 0.08, and so as you can see, we have like we get items in descendant order. Next, what we need to do is we need to install joblib like this, and from joblib we need to import a special function called dump, and we need to create a file where only indices will be contained. For this, it's not form, it's from, let's write indices, pd means pandas series, df index, and index equals to df name, and let's drop duplicates like this, and let's write dump, it should be dump, not dump, indices, and we will call it indices joblib. Let's run it, and as you can see here, we created this file called indices, which we will use later in our course. After this, let's write, for example, a function. This function will show us the places that are similar to our search item. It will take in title, and it will take in cosine similarities like this, cosine similarities, and indices by title. We will pass in the title and we will get the index. Next is we will get similarity scores. It will be the list. Enumerate cosine similarities by ID, and Next, we will sort it sim scores key equals lambda and reverse equals true, like this. And the next, we will get scores for the first 10 items, and movie indices equals I0 for I in sim scores, like that. And then we will return movie indices, like this. So let's check, let's run. Okay, we get an error. It says cosine similarities is not defined. Okay, of course it's not cosine but cosine similarities. Okay, now if we, for example, if we provide a name, for example, let's say we are searching for Ultra Beauty and we need some similar recommendations for this one, we run and we get an error. It says that get recommendations title. Do we have indices? Yes, we do have indices. Oh, okay, let's see. iLoc, it should be with 1C. Okay, and it should be in square bracket. As we can see, we get top 10 items that are similar to this place. We can deduct from this name that it is related to maybe beauty salon, or it's related to hairstyle or cosmetics, or for example to maquillage or something like that. And we get all these places, names of these places. For example, Look Hair Care Studio, Nail Tech, SNK Salon, Aisha African Hair Braiding, and something like that. For example, let's try this one. We see here that it is related to food or pizza, like here, for example, Luciani's Pizzeria and Grill, Candida's Pizza, Parallel Suburban Square, and other places like Wendy's. I don't know why it gives us duplicates. Let's rerun it here. Okay, maybe there are places with similar name. After that, we need to also create a file that will contain cosine similarities. Let's do this. And for this we can write dump cosine similarities, and we will call this file model joblib, like this. And we will also need to have data frame df joblib, like this. And let's do this, and let's see if we have these files. Yes, we do have all these 3 files, which we will use later in our course. Yeah, we will continue in the next lesson. Hi, in this lesson we're starting implementing machine learning recommendation system on our Flask server. If you don't have Python installed and pip installed on your computer, you will find the link to the tutorials that will explain to you. And now I want to show you what you need to do to follow this lesson. First of all, when you open VS Code, you will need to run this command, python space -m -v. It will actually create this file. In this file, you will have all the packages and libraries needed for this particular project. After that, you will need to activate this virtual environment like that, /venv /scripts /activate. After that, you will need to install some packages. For example, you will need to install Flask. You will need to install joblib, numpy, and after that you will need to create this requirements.txt file, and that's it. So in this folder you will have venv folder and requirements.txt. Next, let's create app.py file. You also will need to, wow, what is it doing? You will need to have these 3 joblib files that we created in the previous lesson. You can find these files if you go to, in my case, to users, then this folder, then you need to go to recommender system tutorial. Here we go. You will find these 3 files here. After that, you will need to, it's not here, okay, it's here. You will need to paste it here, okay? Next, let's write a basic HTTP request. First of all, we will need to import Flask. We will need to import load from joblib. Oops, it should be from import. Oh no, it should be import numpy as np, like that. We will need to import, well, do we need to import this one? Okay, let's import. Maybe we will not use it, maybe we will. And let's import UUID. I guess I haven't installed UUID. Let's install it. UUID, like that. Let's regenerate this requirements.txt file, and let's check if yes, we have UUID here. And next, we need to write app equals Flask -- name, and after that we will need to import cosine similarities, like that. Load from, it will be model joblib. After that, we will need to import indices from indices joblib, and next we need to import df, in fact, to load. Yes, like that. Next, let's write a function called get recommendations. This function will take in a title like this, and we need to check if title not in indices, we will return no place titled title found in our database, like that. Next, we need to get index in indices by title. We need to get scores, similarity scores, and we will need to convert it into list. After that, we want to use try and write sim scores equals sorted. We will sort sim scores by key with lambda x1 reverse true like this, and exception as e will print error while sorting like this, and we will return empty array. Next we will get similar scores, 10 scores, and we will write places indices equals I0 for I in sim scores like that, and we will return df lock movie places name business ID to dict orient records. Great. Now let me explain to you how this function works. So this function get recommendations takes in the title, and we check if the given title exists in our indices dictionary. If not, the function returns a message indicating the title wasn't found. For titles in our database, we retrieve its unique index here, and using the cosine similarities matrix, which contains similarity scores between all the places, we extract the similarity scores of the given title with other titles. Then the similarity scores are sorted in descending order. This means places most similar to our given title come first. Then from the sorted scores, we pick the top 10, which starts from index 1, because the most similar item would be the title itself, which we want to exclude. After that, we are only interested in the indices of these top places, so we extract them. And finally, using the indices of the top places, we fetch their names and IDs from our data frame and return item in a dictionary format. And this is how our recommendation function works. By providing title, you can get a list of similar places in a matter of milliseconds. Next, let's write a method. For this, we need to write app root, and the endpoint will be predict like that, and methods will be post like this. Next, we'll need to write def predict, and we need to write request ID equals UUID4. And do we need, well, I don't think we will need it. Let's just comment out here. Let's write let's write title. Yeah, okay. No. We need to write data like that, request, then get JSON like that, and force true like that. Next, we need to write like top 10 equals get recommendations title like this. And in fact, we will write title here equals to data by title like that. And next, after that, we need to return JSONify top 10 like this. Okay, and next, the last piece of code, if name equals main app run host 0 0 0 0 and port 8080 and debug. Okay, and let me explain to you what is this. So in this segment we are going to dive into a simple Flask application that serves recommendations through a web point, and let's break it down step by step. Here we're defining a new endpoint predict that listens for post request. This means when someone sends data to this URL, our server will process it. This function gets triggered when a post request is made to /predict. We first fetch the incoming data as JSON using request getJSON force true. We then extract the title from this data. This title is the name of the place or business for which we want recommendations. And the getRecommendations function, which we discussed earlier, is called with this title to get the top 10 similar places. And finally, we return top 10 recommendations in JSON format using JSONify. And this is standard way to run a Flask application. Host 0.0.0 means that the server is publicly accessible. Port 8080 specifies that our application will run on port 8080. Debug false ensures that the application runs in production mode. If set to true, the server would restart upon code changes, and the error messages would be more detailed. To conclude, by running this Flask application and making a post request with the title, you can quickly get the top 10 recommendation places right in your browser. So in the next lesson, we will use this endpoint, and using Postman will try out this server application. Hello, let's go further with our app. What we need to do is to run our app. We can do this with Flask run, like that. When we run our app, we have this URL, and we can go here and create endpoint here, http / IP address /predict, because we have this endpoint predict. Then make it post request. In body we need to send object title and the name of the place that we need to get recommendations for. We need to choose here row and in JSON, and after that, when we send, we will get a list of objects where we have business ID and name. By the way, if you want to use the same extensions as I do for Postman, you can search here for Postman, this one, and you need to install this. So as you can see, we get recommendations for a certain place. Next, we need to go back to our Node.js app and write an endpoint that will send us these recommendations. So see you in the next lesson. Hello my friends, we are continuing with our project, and in this lesson I would like to write an endpoint that enables us to get recommendations for our app. Let's go to locations.js file in our server folder. We need to write a function. We will call it get recommendations, like this. It will take in request and response as usual. Let's try catch. Here we will just console log the error, like this. We can even return the status 500 and the message, like this. First of all, we need to extract title from breakbody. Next, we need to use Axios. For now, let's use this endpoint. After that, what we need to do is we need to get business IDs like that, and use response. Remember that response is array of objects where we have an ID of a place and its name, item ID, like this. In fact, it's business ID. Then we need to filter out this business IDs and get let's write business IDs like that. Business IDs. Yeah, we need to write a filter to filter out the places. In fact, we just need to get places with IDs. After that, we need to write places await promise all and business IDs map async ID const params table name will be location. Let's take a look. Table name. Yeah, we need just to write table name like that, and we will write key condition expression PL equals PL, like that, and expression attribute values PL. In fact, it's not PL, it is, okay, it's location key in our case, I think, S ID, like that. Next, new query command, we pass in params. After that, we get the data, await DynamoDB send command. After this, we need to unmarshal our data, item unmarshal item, like this, and then we need to return unmarshal items, like that. And after that, here we need to write res JSON places flat, like this. Next, let's write an endpoint here. Let's write app get location and recommendations like this, and we need to pass in this function. Okay, now what we need to do is, I guess we need to test it in Postman. Okay, let's do that. For example, let's use this one, get recommendations, and yes, it will be location recommendations, and let's use this title. Let's try it out. We have very long response. Let's see why. It's probably that we have a mistake, have an error here somewhere. No, it's okay. Okay, I think it's not 3001, it is 3000. We need to cancel this request. Let's try it again. Okay, an error. Location recommendations. Okay, let's rerun this server. Let's take a look what server it is, and the server is 3001. Okay, let's revert to 3001, and let's do again recommendations. Cannot post recommendations. Okay. Oh, okay. It's not, of course, it's post request. It's not get request. In fact, let's do it again. Okay. Request failed with status 4404. Why is that? I think here we should have places, right? Because let's take a look. Here we have, oh, it's not places, it's actually predict. It's predict. And now let's go here and let's make a request again. Okay, version, oh no. So let's take a look. Why is that? Let's go to AWS. Let's go to tables. It should be location key. Okay, let's see if we get response at all. Yeah, we do get a response here. And expression attribute values cannot be specified. Attributes values. Oh, yeah, of course I have typo here. So fix this typo if you have the same mistake. And let's rerun again. Okay, we get a recommendation. It took too long, but eventually we got it. And as you can see, now we get not only name and ID, but we also get full information that we need in front-end part. Okay, I think we are done for this lesson. See you in the next one. So guys, in this part of the lesson, we will display recommendations in our client part. In particular, when we click any item, below here we will see recommendations. It means that similar items to this particular location. Let's go and implement it. Let's go to client, to src, to components here, and we need to create a folder. In fact, I don't think we need to create a folder. We need to write in config, we need to write an endpoint that helps us to get recommendations. So let's go to config, organizations, and here below let's write export const get recommendations async. We will pass in title, and let's return await instance post and its location recommendations. Then here we need to provide title, just like that. Next, this get recommendations we need to use in organization details. Let's go to recommendation details and let's write a state recommendations and set recommendations like that. Use state, and initially it will be an empty array. The next thing is we need to write use effect. In fact, we have our use effect. I don't think we need it. Here in this part, we need to, after we set an organization, we need to import get recommendations that takes in title. It will be data business name like that, and after that data set recommendations data like this. Then we need to display these recommendations. Let's write here, I think we need to wrap it into the div like that. And here let's write another div, or let's write it here, and let's write recommendations map. It will be recommendation and index, and here we need to return another div like that, and inside this div we will have recommendation, I think it's recommendation business name. Let's take a look, and here we will provide a key index like that. Okay, as you can see we have, for example, so this place gives us the following recommendations. As you can see, they are related to school or education. Let's try again for another one. Let's see what this one is recommending. Yep, it recommends different places like airport, stadium. Great. Let's just do a little bit styling here so that it looks a little bit more beautiful. What we can do, in fact, we have container, we have this container details, and this one, let's say it is, let's call it organization details recommendation like that. And this one will be, let's just copy this one and let's write place here, and let's just here recommendation details. Let's just go here and let's write organization details recommendation, and it will be grid, and it will grid template columns repeat for one far and width 600 pixels and gap like 6 pixels, like that. And the each place here will have the following styles. Let's write it here. For example, it will be display flex, will be direction column, and align item center. The width will be 120 pixels and the height will be 150 pixels, like that. And let's write just box shadow, like that. Okay, now we see that we have our recommendations. Of course, it's up to you to style this. You can make it even more beautiful. There is no limit. Let's just center this out. Okay, yeah, of course, you can improve this further, and let's just add margin top 6%. Okay, good. And we can add margin bottom like this. Yes, amazing. Great. In the next part, we will embark on AWS, where we will deploy our machine learning recommender system into EC2 instance, and we will use load balancer to optimize our performance. See you in the next lesson. Hi everyone. In this section we are starting AWS part. First of all, I would like to start with S3 bucket. In this S3 bucket we will upload our files related to machine learning and recommender system. Let's go to this project where we have our recommender system, and we need to add another route that we will need later, and I will explain to you why we need it. Health will be methods, will be get method def check should return healthy and should return 200 status, like that. After that, you need to save this file. We need to create a bucket. Let's give it a name, recommender tutorial, like that. We can leave it by default the region, and let's go to uncheck this one. Let's tick here. Let's just create. Okay, as soon as we create it, let's go here and let's upload our files related to recommender system. Let's take these files and let's drag and drop it into S3 bucket. Now let's go here and let's go to permissions, and here we need to add bucket policy. Now here we need to update this part. We need to write, let's just save this. Now we have our bucket policy updated. We have here, it's okay. Next part, we need to create so-called launch template in EC2 instance. Let's go to launch template and launch template tutorial, like that. Tutorial, like this. And what we need to do is, let's see, yeah, let's choose 3 try eligible, and Yeah, let's just leave it as it is. Here, security group, let's choose this one. And inside advanced details, here we need to paste a code that will help us to automate launching new EC2 instances. Here we paste it here, and let's check. Let's just try to create. Okay, we created our launch template. Okay, next we need to go to autoscaling group. Let's go to autoscaling group. Let's create demo tutorial, and let's choose launch template tutorial, and let's go to next. No AMI specified. Okay, let's go to launch template and try to modify. Probably miss something. AMI. Okay, let's go back to autoscaling group. Here, demo tutorial. No MS. Okay, let's update. Let's choose version 2, and let's go back to autoscaling group. Why is that? Okay, yeah. Next, let's choose all the available, and yeah, we will create later new load balancer. So far, we will not add load balancer, or you know what? Attach new load balancer like that. Yeah, turn on elastic load balancer health check. It will monitor whether instances are available to handle requests. When it reports unhealthy instances, EC2 autoscaling can replace it on its next periodic check. Yes, let's enable group metric collection with CloudWatch. One or more target group is missing. Yeah, target group. Yep, it's okay. And here we specify the desired capacity, the minimum capacity, or maximum capacity. We can specify maximum capacity as, for example, 10, and desired capacity 1. It means that by default we will have only one EC2 instance. Instance scale in protection. If protect from scale in is enabled, newly launched instances will be protected from scale in by default. Let's skip this one and let's review. Now our launch template is being created. Let's wait. Okay, now we have our newly created launch template, and in the next lesson we will continue with this lesson. We will also test our EC2 instance with help of Postman. See you in the next lesson. Hello my friends, let's continue with our tutorial. And in previous tutorial we set up load balancing, autoscaling group, and target groups so far, and in this lesson I would like to walk you through this setup again, because I have made a lot of changes in the code. Basically what I did, first of all, I updated my app.py file, and in this app.py file I have added this port 8081 because the previous port was busy, and I just changed this port. Also, what I did is that in the launch template I have updated, first of all, name, and I updated this piece of code. So this code means that we want to rewrite this line with this, this file with this, with the path from S3 bucket every time we launch new instance. And here I wrote the script so that when new instance is initiated, it runs automatically, so you don't have to run it by yourself. For example, if we look at the instance here, for example this instance, let's just go to WinSCP and access our remote instance using our pair key, and here we have our code copied into home Ubuntu folder. And if you didn't have that piece of code, if you didn't have this piece of code here, this one, if you didn't have this piece of code, you would need to start the server by yourself, for example by Python 3 app py like that, and only that way you would have your server running. But with this script, it initiates it automatically. Also, I have made changes in the target group. I've changed port to 8081, and I have, when I register new instances, I also indicate port 8081 because my app running on this port. I have also changed here, I added this path because AWS needs to hit this endpoint to check if it is healthy or not. For example, if when it hits this endpoint and this endpoint returns to 100, it means that it is healthy, that it is working, functioning. And I also, in the load balancer, I indicated the following properties. For example, I indicated application. It means that we will work with HTTP. And in schema, I indicated internet facing. It means that we can make external requests. And what else? And also in autoscaling group, you can indicate here the desired capacity. For example, it means that you want to have 2 instances working, and it will increase the number of instances automatically. Here I indicated the load balancing I'm using, and you can also set up dynamic scaling policy. It means that, for example, here it means that if average CPU utilization hits 50%, so that you need to have additional instances. It means that additional instances will be created automatically. So what else? And you can use this load instance from template, and you can update, you can increase or add new instances. As you can see, more instances are being added here. And in security group, for example, I used this security group, and you need to add these properties: type, custom TCP, protocol TCP, port range, in our case it's 8081, SSH should be 22, and HTTP should be 800. So 80, sorry. So this 80, it is for internal. It is how load balancing is communicating with instances, and this is for the external. And this means that you can access it from anywhere. And I have also updated, so I used this load balancing in my code. You can get this load balancing here, load balancer. So this DNS name, you copy DNS name and you write here endpoint. That's it. Let's just, yes, as we can see, we get our recommendations in our code. So this is our final application where we used React.js for client part, Node.js for server. We used Flask for recommender system. We used AWS to deploy our machine learning. On EC2 instance, we also used load balancer to scale our application. We also used AWS auto scaling group. I hope that this tutorial was helpful to you. I will provide some external links to tutorials that you will probably need to consult to have a clearer understanding what is going on in this course. And this piece of code is also very important, version 2. So thank you for the attention. Hope this course was beneficial to you. See you later. Goodbye.